Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson here in the world of high school geometry. As you can see, we kind of changed our scenery around here a little bit. I thought that it might make people feel a little bit better, a little bit more at home if we're actually doing a lesson inside the classroom. I realized that those you'll actually sit back in this corner, there'd be people, sitting around in these desks and everything over here. But you know what? They let me in my classroom for about 10 minutes the other day, and one of the things I did was snag a picture of my classroom. I also got to apologize. I've got a little bit of this weird strobing and visual stuff going on here. The reason for that, by the way, is I'm having some lighting issues here in my little home recording studio. I say that. It's a green sheet on a wall behind me with a light down below me. I literally have a light sitting there on the ground. And as you can see, I've got some coloration issues right here where over the shoulder right here is lighter, up here it's darker, and we're having a little bit of problems cutting that out. But anyway, these are the type of things I go through to try and make things look as good as possible for y'all. Now that I pointed it out, you can really see that right there. Anyway, it'll be better whenever I make my face smaller here in a second. Also, you can see that up on the screen over there, I still have my winter background that I never changed. And let's just go ahead and pull our video on there and zoom in on it. That makes it a little bit easier to see. Yes, I know it's crooked. It's the best I can do. That thing is a trapezoid tilted. Okay. Anyway, we're going to get off this view in a second. It won't be nearly as noticeable here in a minute. I got to point this out to you that over here on day 4, this is the last lesson we did. This is our tangents lesson, and we covered that last time. I want you to notice though that we have this day 5, which is secants and tangents in a circle, and day 6, which is special segments in a circle. I'm going to leave these up, and so you can see them. I'm going to try and get the actual filled in notes and everything for these for you guys to look at. By all means, go and look at those if you want to. However, we're not going to be covering those. The reason is, with this distance learning thing, I'm only allowed to do 2 lessons per week, so I had to make cuts somewhere. I felt that those 2 were the least important of the unit, and so I went ahead and cut those out. This one, day 7, which is our equations of circles, is actually going to come up again when we get to Algebra 2. So I decided to go ahead and cover that one so you guys will have that seed planted. Remember, we're in this seed planting business right now. We're not trying to make you complete experts on everything. This is something that whenever your Algebra 2 teacher gets to the equations of circles, you're going to be like, you know what? I remember seeing that. Mr. Love showed it to us. It was distance learning, so I'm not the best at it, and that's okay. The big tidbit here that you really need to get is this technique called completing the square. I can understand that this is going to be sort of like the quadratic equation of geometry class. That one formula, that one thing that you did that just seems so out there and overwhelming at the time, but looking back on it a year later, it's really not that bad if you just follow the process and plug the numbers in and do the process. So we're going to be covering that today. Again, we're planting seeds. We're not becoming experts. So let's go ahead and jump in here and see. I told you it wouldn't be as bad once I got the thing up there. All right, so let's go ahead and jump in here and let's try example 1. So we are going to be solving x squared equals 1600. Now, good news is that whenever you have just an x squared and no x, you can simply take the square root of both sides. So take our square root, and the square root of x squared is x. Square root of 1600 is just 40. So I've got my answer of x equals 40. Easy enough. Probably one of the simplest style of quadratic equation solving that we could ever possibly do. Okay, moving on to, where did it go? Where's number 2? Aha, there's example 2. Solve this guy. Now remember, our typical process whenever we have an x squared and an x in the same equation with our quadratics that have both a x squared and an x term, we want to get everything on one side and then factor, quadratic formula, etc. So let's go ahead and process through that. Let's go ahead and subtract 9 on both sides. That gives me x squared minus 12x plus 36 minus 9 is 27 is equal to 9. Now let's go ahead and see. We're looking for factors, and I'm doing this by factoring for a reason. we're looking for numbers that multiply. I'm sorry, we got x and x. Looking for numbers that multiply to give me 27 and add to give me negative 12. Well, my factors of 27 are 1 and 27 and 9 and 3. Now, it could be the positive or negative versions of those. We could also have negative 1 and negative 27, negative 9 and negative 3. And the reason that they have to be negatives is because if we're going to make them the positive there, it's going to be a positive times a positive or a negative times a negative. So it looks to me, ooh, and I wrote that wrong. Negative 9 times negative 3. It looks to me like if we're looking for something that's going to add up to be negative 12, then we've got these two. So minus 9 and minus 3. Okay, then we're going to go through and we're going to say, split that off into two separate equations. X minus 9 equals 9, and x, well, what am I doing here? I'm going to back up again. That should have been a, rest subtracted 9, 0 and a 0. So x minus 9 equals 0, and x minus 3 equals 0. Sorry, I hope you caught that and you're just saying, what in the world was he putting a 9 there for? Okay, so we're going to add 9 to both sides. X equals 9 and x equals 3. So I've got two answers there. Okay, now we're about to embark on another type of process that is going to be for the first time ever. We're going to be solving a quadratic equation in a way that does not put a 0 on one side of the equation. And that process is going to be called completing the square. Now, completing the square is a process for converting a quadratic equation into a perfect square trinomial. Now, here's what I mean by that. If we had, and I'll cover this whole thing here in a second, okay, what this whole blob is. Let's say that I had x plus 2 squared. Well, whenever I FOIL that out, I'm going to get x plus 2 times x plus 2. You know what? I don't like 2 there. I'm going to use a 3 because it makes my example look better. I don't get 4s over the place. Whenever I FOIL that out, I'm going to get x squared plus 3x plus 3x plus 9. And then that gives me x squared plus 6x plus 9. This is a perfect square trinomial because it came from a perfect square. So anytime that I have a perfect square, I can go ahead and factor it in. Now also notice what happened here. That positive 3 ended up being there, and then here, that is actually a 3 squared. So 3x, 3x, and 3x. So this is actually 2 times 3, and this here is 3 squared. That's what our pattern is there. So what ends up happening is anytime I have this pattern, I can factor back down really easily. So let's just say that I had x squared plus 10x plus 25. Well, here I have that exact same pattern because this is 2 times 5 and this is 5 squared. This guy is going to factor down into x plus 5 times x plus 5 or x plus 5 squared. Oh, and I am in the way of that. Let me jump out of the way. Okay, so we got our pattern here of our 2 times 5 and 5 squared, which factors down to x plus 5 squared. Okay, let's do that again with a different one this time. Let's make it a negative one. Let's say that I've got x squared minus 14x plus 49. Well, that negative 14 is actually negative 7 times 2. Well, actually, I'm going to do it a different way. I'm going to write it as 2 times negative 7. 49 is negative 7 squared. You see, I've got the exact same pattern here as I have here, except it's just a negative 7. So this is going to factor down to x minus 7 squared. Okay, completing the square is a process of taking any quadratic formula and turning it into, any quadratic equation and turning it into a perfect square. And that gives us a little bit of power when we're solving, power that we didn't have before. Okay, so here's what we're going to do. We're going to take our x squared plus bx. All right, now our x squared plus bx would be something like x squared plus bx, which would be this, okay? Remember that ax squared plus bx plus c we did back for the quadratic equation? We're then going to take b and divide it by 2, square the result, and then add that to both sides, okay? That sounds kind of complicated. Let's actually just step through one and you'll see how the process works. Okay, so this right here is my b value. Okay, now again, this is the first time that we're not going to be setting everything equal to 0. Oh, before I do that, let me show the justification for this. If I wanted to try and factor this guy down like it is, here's the problem. I'm looking for numbers that multiply to give me 1 and add to give me 4. The problem is, though, that 1, the only factors of it are 1 and 1, and there's no way to add 1 and 1 to get 4. This guy is unfactorable using the methods that we've done so far. So we've got to add in, or we can add in, this completing the square technique. Let's go ahead and subtract 1. That gives me x squared plus 4x. And I'm going to leave some space here, and it's always good when you're completing the square to leave a little space right there, equals -1. Okay, so in this equation, b equals 4. So what I'm going to do is I'm going to do b over 2, which is 4 over 2, and then squared. So 4 over 2 is 2. 2 squared is 4. That came from this guy right here. Okay, that's why we're doing that. Now we're going to add that to both sides. X squared plus 4x plus 4 equals -1 plus 4. Because remember, by adding something to both sides, I don't change the equation. Now, let's look at the beauty of what that does for us. Now this is 2 times 2, and 4 is 2 squared. That exact same pattern that I had above. So what that means is this guy factors on the left to x plus 2 squared equals -1 plus 4 is +3. Now I've got a square term on the left. I can take the square root of both sides, and my squared and my square root cancel, leaving me with x plus 2 is equal to the square root of 3. Now we got to do something a tiny bit different here, because whenever we introduce a square root into the middle of an equation, we've also got to introduce in another symbol here, this plus or minus symbol. Now the reasoning for that is that whenever I take the square root of something, whenever I square something, it doesn't matter if I squared a positive or a negative, I'm going to get a positive result. So whenever I'm undoing the square, I've got to account for both versions of that. Okay, so this is positive or -3, or positive or negative square root of 3. Now we're going to subtract 2 on both sides, so -2, and that's going to leave me with x equals, and now we're going to put the -2 out in front, plus or minus, and then the square root of 3. Now, you'll notice that this answer starts to look a lot like that quadratic formula answer that you got way back in Algebra 1. The reasoning for that is that the quadratic formula is actually just a formula abstraction of completing the square. If you're interested in that, I can show you that at some point, but that's not the purpose of our lesson today. So, 2 answers here, -1 plus the square root of 3, -2 plus the square root of 3, and -2 minus the square root of 3. Did you get that? I know that was complicated. We're going to do it again. The next one will make a little bit more sense. By the way, if you need to, go back and rewind and watch that section again if that was intense. Okay, let's do it again. This one, we've already got our 5 on one side, and we're going to leave it that way. Once again, there's not going to be, well, let's take it back. Let's see what we get here when we do completing the square. Here, our b value is 6. So we're going to do b over 2 squared, which is 6 over 2 squared. 6 over 2 is 3, squared is 9. So we're going to have x squared plus 6x. Now remember that space I told you about earlier that I'm leaving. I'm going to add 9 to both sides. Now what that reduces down to is x plus 3 squared is equal to 5 plus 9 is 14. Okay. Oh, by the way, you'll also notice this pattern on both of them. Here, our b over 2 is 2, which is the exact same number I got there. Also, here b over 2 is 3, which is again the exact same number I got there. Not a coincidence, it will happen every single time. Now let's take the square root of both sides. X plus 3 equals plus or minus the square root of 14. And now we're going to subtract 3 on both sides, leaves me with x equals negative 3 plus or minus the square root of 14. There, that wasn't so bad. Okay, again, if you need to, go back, rewatch that example, and then hopefully this will make a bit of sense. If you need to, by the way, Khan Academy has some great examples on completing the square. But feel free to just Google Khan Academy completing the square, and they've got some great ones there if you need a little bit more help on that. Okay, now, why in the world would I ever want to do that? The equation of a circle. We're going to be using that skill in order to take equations and manipulate them into the equation of a circle that I need in order to graph it. Now, here's the standard form for the equation of a circle. X minus h squared plus y minus k squared equals r squared, where h and k are the x and y coordinate of the center of the circle. So here's what I mean by that. If I have a circle that has a circle or a center here at 3, 1, and its radius is 5, then the equation of that circle, by the way, this is hk, the equation of that circle is x minus h, so minus 3 squared, plus y minus k, where k is 1 squared, equals 5 squared, or you might see that written as 25, depending on how the problem writes it or how you solve it. Notice though that the 3 is positive in the coordinate position. Okay, it's positive here and negative here because we changed the sign when we added into the equation. So if it was a negative coordinate, it would be a positive version in the equation itself. Okay, so let's do another one here where the equation is centered at 2, negative 3 with a radius of 1. Now we're going to have x minus 2 because we changed the equation or changed the sign, squared, plus y. Now my y coordinate is a negative 3, so we're going to make this a positive 3 squared equals 1 squared or 1. That's how I write the equation of a circle. Okay, let's do a few of these. Write the equation of the circle with a center at negative 2, negative 6, and a diameter of 8. Well, if the diameter is 8, then that means that the radius is 4. My equation was x minus h squared plus y minus k squared equals r squared. So that gives me x. Now, this is hk. So x plus 2, you change in the sign, plus y plus 6, you change the sign, equals r squared, which is 4 squared, or 16. There we go. Simple enough. Now let's do number 6. Write the equation of this circle. Now this one is already graphed for us. So we got this point is 3, 3. We got to find the coordinates of the center. So my center here looks like it's going to happen at 1, 3, which means that the equation x minus h squared plus y minus k squared equals r squared. Here's hk. And then looks like r is going to be 2. So that's going to be x minus h is 1 squared plus y minus k, which is 3 squared, equals r squared, 2 squared, or 4. Okay, so all we're doing is finding the pieces that we need. Find h, find k, find r, plug them into the equation. All right, write an equation for a circle that has a center at 4, 5 and passes through the point 7, 1. Now, this is going to be a little bit more difficult because you have a tiny bit more solving to do. First off, I'm going to graph this and see where we're at. We got 4, 5 is right here. And then it looks like 7, 1, I'm going to put about right there. And so my circle is going to go around like that. Let's pretend that's a good circle. Okay. Now, the question is, what's the radius of this thing? Well, for my radius, I'm just going to come in and find this distance, which is my hypotenuse for Pythagorean theorem, or I can do distance formula there. So d equals the square root of plus squared minus minus, so x2 minus x1. Let's use this one as x1, y1, x2, y2. So x2 minus x1 is 7 minus 4, y2 minus y1 is 1 minus 5. 7 minus 4 is 3 squared plus negative 4 squared. Well, actually, that's a 3, 4, 5 right triangle, so I know that my answer is going to be 5. So distance is 5. In this case, it also means my radius is 5 because it's the radius of the circle. Now, here is my h and k, because that was my center. Let's actually write a k there instead of a 5. Okay, so now x minus h squared plus y minus k squared equals r squared. That's going to give me x minus 4 squared plus y minus 5 squared equals my radius, which is 5 squared, which is 25. Not too bad. 3 more examples. And I know the 3 is 3, take up the entire backside of that notes page. It's not going to be that bad. Okay, we want to set the coordinates of the center and then graph the equation. I believe that on yours, you've got the center and then the radius. Okay, we're going to work our way backwards here. Write the equation of the circle. So remember, this is at HK, and here is our HK. So we're also changing the sign. So if it's negative 2, then this is a positive 2 for h, and since it says y minus 1, that means k is a positive. Then this is an r squared, and if r squared is 9, then the radius is 3. Oop, got off my screen there. So let's go ahead and jump in there. Over 2, up 1. There's my center. Radius is 3. So from here, I'm going to go out 3 in every direction. North, south, east, and west. 1, 2, 3, 4. And then, well, 1, 2, 3. And then again, we're going to pretend like I can actually draw a circle. All right, number 9. All right, it looks like I've got to do some rearranging on this one. So I'm going to say x plus 2 squared minus 16 equals negative y squared. Now, I know that I need to get my y squared over on the left-hand side of the equation. I just realized I'm backwards there. I'm pointing left. Okay, let's go left. Okay, so we're going to add y squared to both sides, and we're going to go ahead and move the 16 over as well. So I'm going to do plus 16 on both sides. That's going to give me x plus 2 squared plus y squared equals, and my 16 is on the right because those guys subtracted out and those two subtracted out. Now, what are the equation of, or the value of my center? I'm sorry, the location of my center, and what is my radius? Well, I need h and k. So it looks like here I've got h is 2, but then I'm missing a k value. But remember, this is essentially the same thing as y plus 0 squared. So it looks like my k is going to be 0. So h is negative 2. Remember, we're always changing that sign. K is 0. And then my radius is, so this is the same thing as 4 squared. So 4. So we're going to negative 2, 0. There's my center. And I'm going to go 1, 2, 3, 4 in all directions. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And if I was actually on paper, I would use a real compass to make that be perfect. But, you know, we do the best that we can. All right, number 10, last example. Let's throw this whole thing together. And this is where we're going to actually use our completing the square skills to come up with our answer here. Now you'll notice that I have x squared and x in the equation. I've also got y squared and y in the equation, but I don't have all the things necessary in order to have a perfect square trinomial of either x's or y's. So what we're going to end up doing is we're going to end up completing the square 2 times, once for x, once for y. Now that sounds complex at first, but just follow me through here. We've got x squared minus 4x, and remember that space I was telling you about earlier. Now we need plus y squared plus 6y, and let's go ahead and leave that space again. Oh, don't need quite that much space. Equals negative 9. I'm color coding this so you can see it a little bit better, and I probably should have done this at the very beginning of the video. I'm going to go ahead and make my purple a little bit bigger. Plus y squared plus 6y, and then space. Okay. Now we're going to do the b squared, or b over 2 squared, for both our x's and our y's. So for our x's first, b over 2 squared is negative 4 over 2 squared. Now negative 4 over 2 is, oh, it's cutting me off. Okay, that is negative 2 squared, which is 4. Now, I'm going to go ahead and do this exact same process for my y's as well. And I'll come back and actually use these in a second. B over 2 squared is 6 over 2 squared, which is 3 squared, which is 9. Okay, now let's actually do something with this. Taking our green 4, okay, the b over 2 squared for the 4, or for the x's. I'm going to add 4 on the left and add 4 on the right, because what I do on the left, I must also do on the right. Now we're going to do it for our y's. We're going to add 9 on the left and add 9 on the right. Okay, I hope you're with me so far. We've just completed the square for both of them. Now, here's why that's important. Because this, now the x terms, now simplifies down to x minus 2 squared. Remember, this minus 2 and this minus 2 are the same thing. Plus y plus 3. Once again, this 3 and this 3 are going to be the exact same thing. You know what? I'm going to go ahead and leave that highlighter there. Equals, now let's combine our like terms on the right. Negative 9 plus 4 plus 9 is 4. Ooh, I forgot my squared on my y's. Okay. Now, we can see exactly our circle equation here. X minus 2 squared plus y minus 3 squared equals 4. So here's my h. Here's my h. Here's my k. And here's my r squared. So my center for this problem, center is located at hk, which is positive 2. Remember, change the sign. Negative 3, change the sign, and my radius here is square root of 4, so 2. So we've got 1, 2, negative 3. There's my center. My radius goes 2 in all directions, and there it is. So here is the summary of that entire thing. First off, you're going to do the b over 2 squared, the completing the square step for both the x's and the y's. You're going to add that b over 2 squared to both sides. Okay, that's where we're adding the 4 in green, adding the 9 in purple. Then we're going to factor the x's and factor the y's separately. That's why all the greens, I guess on this side, sorry, all the greens got factored down to x minus 2 squared, and the purples, y's got factored down to y plus 3 squared. Then we're going to just pick off all we need from our circle, h, k, and r. Okay, I hope you didn't find that too difficult. Like I said, you've got the recording, so you can always go back and oh, wrong one there. You can always go back and rewind. Feel free to look stuff up, ask me questions, send me emails, Google Classroom questions, whatever you need. And I'm going to go ahead and cut it. This one's a little bit longer than normal. We're at 32 minutes. I apologize for going a little bit long. I'm trying to keep these to 30 minutes or less. But I'll see you guys whenever possible. Yeah, stay safe, stay healthy, guys. Stay patriotic.